In today's demonstration, we'll be showing you how we use the LaserDyne process calculator for a welding application. In this application, we'll be welding a butt joint to nickel-based superalloy. Material thickness of both components is 3.0 millimeter. The first thing that I will do is specify the type and power of the laser being used. For this application, I will be using a LaserDyne 430BD with a convergent 3 kilowatt fiber laser. Given the large top bead requirements, I would like to see a 1 millimeter spot size at the workpiece. In order to achieve this, I will start by selecting a 400 micron fiber. For the collimating lens, I will select 120 millimeter, which is our current standard. Next, I will choose the focal lens that we will be using. In this case, I will use the 300 millimeter lens in order to achieve the required spot size at the workpiece. We will start our trials with focus on the surface, so I will select a 0.0 defocus. As you can see that this optics configuration at 0.0 defocus has given us our required spot size of 1.0 millimeters at the workpiece. In many applications, we would select CW mode, then set our peak power and feed rate to achieve the desired weld shape. In a typical automotive application, we could achieve feed rates of around 4 to 5 meters per minute, utilizing the maximum power of this laser. In today's demo, we will instead select pulse so that we can achieve maximum penetration while still inputting minimal heat into the material. Pulse width will be based off of experience with a similar application. I will begin trials at 8 milliseconds or 0.008 seconds. If I find that the weld width is too large, I will decrease the pulse width, and if it is too small, I will increase the pulse width. This is how we would change the shape using the pulse width. Next, I will specify the pulse frequency. Again, I know from experience that a pulse rate of 75 Hz will give minimal heat input while still achieving a hermetically sealed weld at a preferred feed rate of 800 to 1200 millimeters per minute. I will select a peak power of 3 kilowatt to achieve the weld depth requirement. If the weld depth is too deep, I would decrease this until the requirement was achieved. Feed rate is based off of the calculated spot size, the frequency, and the pulse overlap requirements. This application requires a hermetically sealed weld, which equates to a 70% overlap or more. In this case, a feed rate of 1000 millimeters per minute will help us to achieve a 78% overlap. After we have entered the initial round of inputs, we can begin reviewing the calculated outputs. It's important to note that the first 5 items have been directly copied from the input selection. You can see that we are working with a 3 kilowatt laser, 400 micron fiber, 120 millimeter collimating lens, a 300 millimeter focusing lens, and the defocus is set to 0.000. The outputs for this is going to be a beam diameter of 20.2 millimeters, spot size on the surface 1.0 millimeters, depth of focus 2.5 millimeters, defocus spot size 1.0 millimeters. It is also important to notate that the numbers that are on the left side of the screen have also been updated live into the graphics on the right side of the screen. The next step is to make sure that we have a spot diameter at the part that will be adequate for bridging the joint. Based on the current inputs, which are the 400 micron fiber, the 120 millimeter collimating lens, the 300 millimeter focus lens, and the 0.0 defocus, the calculator shows that the focus spot size is 1.0 millimeter and the depth of focus is at 2.5. Fit-up requirements typically are not to exceed 10% of the material thickness in order to eliminate any kind of undercut the weld crown. In a precision application such as this, we will see requirements that are much tighter. In this case, the fit-up requirement is 0.1 millimeters or less. If it were necessary to enlarge our spot size for the fit-up, we would use the defocus calculator to determine the amount of defocus to achieve the desired spot size. Given the large depth of focus and the long focal length, it may be necessary to defocus a large amount in order to achieve the desired spot size. In this case, we would need to defocus 10 millimeters in order to achieve a spot size of 1.5 millimeters. Another very important consideration is the type of gas that we will be using, along with the delivery method. Given the requirements of this weld, I will use our Smart Shield weld nozzle along with a coaxial tip to deliver gas to the process. I will start by using nitrogen as our process gas, being delivered at around 70 liters per minute or 2.5 SCFM. With these parameters as a starting point, we are now ready to move to the machine and begin trials. This concludes today's demo. Thank you for watching it. If you have any questions or would like to discuss the use of the calculator for your specific application, please feel free to reach out to us using the email address on the screen.